Today we're going to take a look at law of sines. So the first thing we're going to do is take a look at this triangle, and it's a non-right triangle. So we can't use the SOHCAHTOA that we've been working on. So it says the first thing to do is draw a perpendicular line from B to the base of the triangle and name it H. And so that's perpendicular. So now we have two right triangles. So then find the sine of A and the sine of E. So the sine of A, opposite over hypotenuse, and so we're just looking at this triangle right here. So that would be H over C. And then the sine of C, opposite over hypotenuse, that would be H over A. Solve for H. So if we solved for H, so H over C multiplied by C, so we'd have C times the sine of A equals H. And this one was H over A, so multiply everything by A. A times the sine of C equals H. So we have two H's there, so that means C times the sine of A, that's one H, has to equal the other one, A times the sine of C. Divide each side by AC. So let's write this out again. So we have C times the sine of A equals A times the sine of C. So divide each side by A and C. So A and C, A and C. So the C's, the A's. So what are we left with is the sine of A over A equals the sine of C over C. And now it says repeat it again. So what we're doing, what it says for step 5 here is we kind of just rewrote the triangles with A, B, C, but I bet we can infer what happens if the sine of A over little a equals the sine of B over little b, or excuse me, we have C, jumped ahead there. C over little c equals the sine of big B over little b. So in this case, it's really important to remember the capital letters are the angles and the lower cases are the sides. And what this is the law of sines. So on this next page, we're going to be solving using this law of sines. So we're going to take a look at a couple of these. And as you can see, we're going to take a look at these top two first. And let's see. See if I can add a page here. Whoops. Get this organized. We need to add a page. Oh, there it is. We need to recut this. Let's see. Sorry about that. Let's see if we can try this one more time. So to solve for C. So let's see. We have an angle and the side opposite, and then we're trying to find, let's see if we can match these up here. And there's a pair as well. So to set this one up, we'd say the sine of 103 over 26 equals the sine of C over 25. If we fraction bust this, we got to multiply by 26 and 25. So 25 times the sine of 103 equals 26 times the sine of C. So let's see, to get C by itself, divide by 26. And let's see what we get for that. So 25 times so we end up with 0.93 equals the sine of C, and since we're finding an angle, we have to do that inverse. And if we do that, we end up with 69.5 degrees. So if we take a look at this next one here, what do we have? We have, here's an angle on the side the opposite, angle the side opposite. So we could set this one up, the sine of 53 over B equals the sine of 44 divided by 7, multiplied by 7 in B. So we have 7 times the sine of 53 equals B times the sine of 44. Divide by the sine of 44. And we have 7 times the sine of 53 divided by the sine of 44. I have B equaling 8.05. So what I want you guys to do is take a look for these next couple here and see what you can come up with. Pause the video and then try these and then start it again and see what you got. So let's see if we match up these sides here and angles, so we could set it up the sine of 25 over 12 equals the sine of A over 18 multiplied by 12 and 18. So now we have 18 times the sine of 25 equals 12 times the sine of A. Divide by 12, 18 times the sine of 25. I feel like something went off here. Oh, whoops, I typed it in the calculator wrong. That's why my number wasn't making sense. Divided by 12. So we have 0.6339 equals the sine of A. Alright, so let's see here. And then we do that inverse. And we end up with 39.3 degrees. So if we take a look at this next one here, see what we can match up. We can set this one up, the sine of 81 over 22, the sine of 47 over C, multiply by 22 and C, so we have 22 times the sine of 81 equals, that wouldn't be 22, excuse me. We'd have C times the sine of 81 equals 22 times the sine of 47. Divide by the sine of 81. And we have 22 times the sine of 47 divided by sine of 81. C equals 16.3. Now the last thing we're going to talk about today is area of a triangle, because this law of sines, how we came up with it, can help us find the area of a triangle. So as of now, we know area is base times height divided by 2. But we might not always be given the height. So if we had, let's label this A, B, C, so this would be capital C, capital A, capital B, and we need to find the area of this, but we're not given the height. Well, if we were to drop down this height and make it just like we did with the law of sines at the beginning, we could say that the sine of A equals H over C. So H equals C times the sine of A. So our area formula, base times height divided by 2, we now have a different way of rewriting this height. So our base is still B, but now our area formula would be B times C times the sine of A divided by 2. And what happens if we were to work this out, as long as we have, you'll notice we have B, C, and the sine of A, it works for any two sides and the included angle. So if we look at a triangle right here, if we had 8, 5, and this was 42 degrees, we could easily find the area. It would be 8 times 5 times the sine of 42 divided by 2. And that would be your area.